Problem 5. The number n is a two-digit number. When n is divided by 9, the remainder is 1. When n is divided by 10, the remainder is 3. What is the remainder when n is divided by 11? Well, n would be congruent to 1 mod 9. And we also know that from these statements, n will be congruent to 3 mod 10. Now, the interpretation of this is basically where when n is divided by 9, I get a remainder of 1. It's very simple. But with two-digit numbers in modular arithmetic, we typically like to simplify them into the summation of its digits, which is 10x plus y. This is the deconstruction of a two-digit number, and for most two-digit number arithmetic modular arithmetic questions, we typically do this. So with this understanding, let's rewrite statement 1 to be 10x plus y is congruent to 1 mod 9, and let's rewrite the second statement, 10x plus y is congruent to 3 mod 10. Now, I'm going to write down a few numbers just to show you what we have here. We have 9, 10, 11, 12, 13, 14, 15, 16. Now, when this is divided by 9, right, mod 9, what do we have as the remainder? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and then when we get to 18, we get back to 0. Why? Because 18 is a multiple of 9. Now, let's do mod 10. When we have mod 10, we have what? We have 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And you see where this goes. So what we have here is that when this n, right, is divided by 10, I have to have a remainder of 3. And only when I have a units digit of 3, as you can see here, do I have a units digit of 3 for mod 10. So what this basically means is y has to be 3, right? So if y is equal to 3, then this becomes 10x plus 3 is congruent to 1 mod 9, right, from what we have here, and 10x plus 3 is congruent to 3 mod 10. Now obviously, this is always true for all x's, so let's only focus on statement 1. Right? For statement 1, we can we can subtract constants on both sides and not affect the arithmetic, so therefore this becomes 10x is congruent to negative 2 mod 9. Now, one thing about this term right here, the remainder, is that the remainder can be added by multiples of 9 to get to various remainders. So in other words, 10x is congruent to negative 2 mod 9. Well, by this statement, 10x is also congruent to 7 mod 10. Right? And the reason why this works, right, is because, remember, we can add negative 2 plus 9k, where k is 0, 1, 2, 3, etc. So with this understanding, what can we say? Well, we can also say that 10x, right, 10x is much larger, or this is supposed to be mod 9, sorry. 10x is much larger than 9. So what this basically means is we can reduce 10x. What is 10x when divided by 9? Right? Well, we can put an x here, and we say 9x, that simplifies to x. So in other words, this can be reduced down to x is congruent to 7 mod 9. Now let's see on our chart where this is true, right? It's only true, actually we don't have to do anything further, right? Because when we get to this statement, what else can we say? Well, we can look at the chart to get our final answer, but they have to be both the same, right? It has to be both satisfying the first and the second statement. And what I mean by this is this statement right here, x is congruent to 7 mod 9, must also correlate with this statement where 10x plus 3 is congruent to 3. So in other words, we can say that x, right, what will x be equal to? Well, x is no longer congruent. X is equal to 9k plus 7. Right, 9k is a multiple of 9. We add 7, so we always have a remainder of 7 when we divide this by 9. But then we have to make sure this works for the second equation. So what we can say is we can say that 10 times this plus 3 must give our number. Right, 10 times 9k plus 7 plus 3 must give some number, let's say y. And that will work because, again, we're just following along with what we need to do. We have to satisfy both the mod 10 and the mod 9, so we plug x into the mod 10 and we get this expression. So y must be equal to 90k plus 73. And what we're trying to find here, we are trying to find what is the remainder of n when it is divided by 11. What is the remainder? Well, n, right, can be any number where k, right, is any multiple starting from 0. So in other words, what we can say here is that we can say z is congruent to 73 when we have a mod 90. And that's obvious because we have 90c. But alternatively, we can also use the system of modular equations to immediately receive x is congruent to 73 mod 90. Well, yeah. And then to prove it, well, 90 plus c, 90c plus 73 is congruent to a mod 11. So then if we divide out the 11s, we get 90c plus 7 is congruent to A, right? That makes sense. So this is our n, right? Let's get this sorted out. This is our n number, but then this n has to be divided by 11. So what is 90k plus 73 congruent to when we mod it by 11? Mod 11. Well, we don't know, so let's call it I don't know. Let's call it A. Well, if we have an A, we can reduce 73, right? 73 divided by 11. So we put a 6 here, 66. That becomes 7, right? And what is 90k? Well, for 90k, we don't really do anything with it because 90c is always representing of the number. So 90k just comes down here. 90k plus 7 is congruent to A, and since k can be equal to any number from 0 all the way until, whatever, we want to find the smallest, so k is equal to 0, so that means A is congruent to 7, and that's a remainder, so therefore your final answer will be answer choice E.